A deeper look into electrolytes. They are formed with ions. They are from an electrolytic dissociation. We'll have a look at their strength once the electrolytes are in solution. All atoms have a set number of electrons and protons that renders them neutral. That is why sodium, with the atomic number 11, has 11 protons that are positively charged and 11 electrons that are negatively charged. Because each electron has a proton, it is therefore neutral. All atoms also have a set number of valence electron that can be found on the outermost shell. That is where the activity or in the bonding happens. The atoms therefore can gain or lose electrons and become an ion. An atom that gains electron becomes negatively charged, while an atom that loses electrons becomes positively charged. We have nickname for those negatively charged ions. We call them anions. And we have another name for the positively charged ions. We call them cation. You might be wondering, how does an atom become an ion? Well, the atoms become ions by following what we call the octet rule. This rule allows a full valence shell, usually made up of 8 electrons. As a general rule, metals tend to lose their valence electrons and become positively charged ions. Oppositely, nonmetals tend to gain electrons to fill the valence shell and become negatively charged ions. Let's have a look at the table below. We have the group number up above. Just under, it tells us just how many valence electrons each of the atoms of that group have. For example, in group 1A, all the atoms have one valence electron. They tend to lose this one electron and become positively charged ion. Moving up to group 2 and 3, the same process happens, but with losing 2 or 3 electrons and becoming positively charged ions by 2 or by 3. Group 4 is a tricky one because it can either gain or lose these 4 electrons. Therefore, they will form either positively charged ions or negatively charged ions. Then we slipped into the groups that are more, well, they have more valence electrons, such as group 5, 6, and 7, who each have 5 electrons, valence electrons, 6 valence electrons, and 7 valence electrons. They will not lose those electrons because it takes too much energy. They will gain electrons in order to fill the octet rule and end up with 8 valence electron. By doing so, they become negatively charged ions. If we want to have one quick look at group 8A, where noble gases are located, they already have 8 valence electrons. So they are extremely stable, will not lose or gain electrons, and therefore will not form any ions. Ions of positive and of negative charges are often attracted to one another because opposites attract, and they will form ionic bonds. Ionic bonds are common in molecules containing metal as they tend to lose electrons and become positively charged, and combine with a nonmetal which tends to gain electron and become negatively charged. Or If it's not a nonmetal, it may be a group of nonmetal known as the polyatomic ions because it contains, such as SO4, several nonmetal atoms bonded together. You've studied electrolytes in the past, and you've come to realize that electrolytes, because of their ability to separate or dissociate once in a solution, they allow the electrical current to flow through them. We will have a look at the strength of electrolytes, which calculates the proportion of ions that are loosely floating in the solution as compared to the number of complete molecules that are in that same solution. Needless to say that the greater the dissociation, the stronger the electrolyte. The only way to test the strength of an electrolyte is by measuring the quantity of electrical conductivity that is allowed. And when you compare it to other electrolytic solution, make sure that you have the same molar concentration, or else your comparison will not make sense. And here's an example of how we can qualitatively measure the strength of an electrolyte. We put a anode and a cathode inside of a solution. We connect that to a light bulb and allow for the electrical power to go through it and see the results. Ethanol does not conduct electricity. Therefore, ethanol is not an electrolyte. If we look at the solution of KCl, potassium chloride, we see that the light bulb is very bright. This means that potassium chloride is a very strong electrolyte. Because acetic acid will only light the bulb in a dim fashion, it allows only for a low quantity of electricity to go through. This means that acetic acid is only a very mild electrolyte. In order to finalize our study of electrolytes, let's review electrolytic dissociation. Electrolytic dissociation happens when a molecule of an electrolyte is dissolved in water and it dissociates into its ions. For example, the salt sodium chloride in its solid form, when rehydrated in water, will form some aqueous sodium ions along with some aqueous chlorine ion. Same would happen with magnesium hydroxide. It once would be dissolved in water, would form some magnesium aqueous positive ion, and for each one of those magnesium ions, it would produce two hydroxide ions. And here's another example with a polyatomic ion, the sulfuric acid. If we have a liquid sulfuric acid and we dissolve it in water, we would have two ions of hydrogen for one ion of sulfate. Hope this helps. In summary, what you saw in this lesson is that atoms become ions by either gaining or losing electrons. They do that by following the octet rule. You also saw that ions of opposite charges easily bond together. Electrolytes are substances that, when dissolved in water, allow the electrical current to flow. Electrolytic dissociation is the separation of a dissolved substance into two ions of opposite charge. The strength of an electrolyte can be measured as the amount of electricity that flows through a solution.